Excellent.
Good afternoon, everybody, or morning. Thank you for joining us today. This is our last of a series of what started as webinars, and now we're doing as a Zoom call so we can engage you a little bit more personally in this last session. I'm Dwayne DeFries, Executive Director of the IRL Council and Indian River Lagoon National Estuary Program. And many of you have been with us through this entire contract period, and I want to thank you for sticking with us through the year. And those of you who are coming on for the first time, welcome. We're really glad to have you. The first set of webinars, which is over a year ago, demonstrated the power of GeoCollaborate as a data sharing tool and a communication tool for Indian River Lagoon harmful algal blooms. And in that series of sessions, we focused on the 2016 harmful algal blooms in the Indian River Lagoon. The second set of sessions showcased GeoCollaborate as an emergency response communication tool, both with bloom responders as a target audience, but also with the media and the public. So how do you operationalize data to take action during an event? And in this third and last series, we'll showcase GeoCollaborate as a statewide dashboard for communicating the status of harmful algal blooms and sharing data. What precipitated this grant from the Florida Department of Environmental Protection, and the funding came through DEP's Innovative Technology Project Grant Awards for harmful algal blooms, was recognition among all of us that, communicating data was important, getting that data to the key stakeholders who either make decisions or are doing research was important. We want to showcase and test GeoCollaborate as a tool for harmful algal blooms. And prior to this grant, that had not been done before, although Dave Jones and Ellen will talk a little bit about GeoCollaborate and its origin. Today, we're going to actually look at the statewide view. And before we begin, I want to just introduce my entire team, thank them for their hard work, and also thank DEP for the funding. So with us today is Kathy Hill, National Estuary Program Deputy Director, Dan Kolodny, our Chief Operating Officer. Dan's going to manage the questions you pose in the chat, but we really want you engaging either directly by raising your hand, we'll recognize you, or if you want to write your question in the chat along the way, feel free to do so. Erin Bergman, a new staff member, is our new administrative coordinator, and KJ Ayers, who you will hear from today, is our new GIS scientist. And KJ's been working with us for the last 12 plus months on this project. She has been the workhorse on data management, QA, QC, and has really been a driving force with Dave and Ellen on this project. Also, I want to introduce three new staff members that many of you have not met before, and some are coming on with us just this week. We have added 3 regional community engagement coordinators. Jesse Wales will be representing Volusia and Northern Brevard County. Heather Stapleton will be representing Southern Brevard County and Indian River County. And Kalita Scott, St. Lucie and Martin counties. And they started, now we have a full team this week, and I urge you all to reach out as we move forward into 2023 and engage with our new staff. And lastly, I want to recognize our senior scientists. We couldn't have done this without their help and without their help with data. So Dr. Chuck Jacoby with St. Johns River Water Management District and Dr. Dennis Hanasak with FAU Harbor Branch Oceanographic Institute. Dennis couldn't join us today, but it was their data sets and their oversight that made this project possible. So again, we're conducting this as a Zoom meeting. We're hoping you interact actively and that we get some discussion along the way. And then I'm going to introduce our Storm Center communication team, who's going to lead this Zoom call today. Dave Jones, the founder and CEO of Storm Center Communication, and also Dr. Ellen Prager, Chief Scientist at Storm Center. So Ellen, why don't you take it away and we'll start the show.
Thank you so much. And thank you again for everybody for joining us today. I want to reiterate what Dwayne said, and please feel free anytime to put your questions in the chat. We will stop periodically and ask if there's any questions. We really encourage you, if thoughts come up, even if we're in the middle of things, if something comes up that you think of, throw that in the chat question. During the previous webinars, we showed on a split screen how GeoCollaborate works with the leader-follower sessions, where a leader puts data sets up on maps and they automatically appear on the followers map. So you're looking at the same map at the same time. The data is not downloaded, but you have access, it's queryable, and we're going to show that again. But today what we're going to do is we're going to focus on bringing a variety of types of data sets from multiple sources onto a map, showing a statewide map, looking at some specific regions, but we're not going to do that split screen thing again, because we don't want people to be distracted by it, the idea of it going from the leader to the follower. Hopefully you've been on and you've seen that. And then we're also going to look at the dashboard that is automatically created after each active leader follower session. One thing I want to again make clear that we've said every time is that GeoCollaborate is not meant to replace any portals, hubs, or websites that people have created to get access, to get people get access to their data, to download data. That's not what GeoCollaborate does. But in fact, GeoCollaborate can help provide access from or to those portals. If GeoCollaborate goes to those portals to get data, the metrics will show people are using the portal. So we like to say it doesn't replace portals and hubs, it turbocharges their use. Always want to make that clear. So what we're going to do is we're going to start by looking at a variety of data sets statewide. We're also then going to go down and look at specific regions. And then we're going to have some, hopefully, discussion, not only among ourselves, but with some of you out there about other data, what else can be done, what's the future. So let's get started. Dave, I'm going to turn it over to you now.
Thanks, Ellen, very much. And thanks, Dwayne, for the introduction. Good morning, everybody. I'd like to first describe what I'm going to be doing. I have up on my computer screen, I haven't shared it yet, but I've logged into GeoCollaborate as a leader. So I've entered credentials. And what I'm going to do is I'm going to share my screen. And by doing that, I'm going to make sure I share the right browser here. And what should be coming up, and now if you can just give me a thumbs up, you can see the screen okay. And what you see is a satellite picture, and you see some radar data on top of it. This is GeoCollaborate, and this is GeoCollaborate Live, actually. If, as Ellen said, we were doing the leader follower, if you were connected to this instance as a follower, you would be receiving this data in real time on your device, whatever platform you were using. And you may have just seen the radar data updated. Interestingly enough, I've zoomed out a little bit wider today because there's actually an active tornado warning in the Dallas-Fort Worth area right now. You can see the strong line of thunderstorms that are moving through Texas. This is going to be a very active severe weather day in the southern part of the United States. So we're keeping an eye on that. But I'm going to move down towards Florida, and you can see this is a satellite image. It's a visible, meaning whatever is reflected by the sun during the daytime. The GOES satellite from NOAA is processing this, taking this imagery, and it's updated every 10 minutes. So this imagery is up to date. The radar data is updated every 6 to 11 minutes as well. And what you see on the east coast of Florida are a bunch of dots. That's the Indian River Lagoon. In previous webinars, we've shown you some of the data from Indian River Lagoon. And so I'm just going to show you, you'll be able to see me interact with the menu. I'm going to turn off the NOAA satellite data. And that's here, the true color full disk image. And when I turn that off, you see the The radar data remains, so you can see exactly where it is raining, a few showers in the IRL this morning. But I'm going to zoom down into the IRL so you can just see some of the observation points. We've talked about this in the past. This is, and I can turn off the weather radar data as well. And when I turn that off, that disappears for everybody. But these are level areas of observations within the IRL that are taken so data can be monitored. And also, one of the other data sets that we displayed before in previous webinars is the vectorized chlorophyll A data. This is based on satellite imagery. And as I zoom down into the IRL, you'll see this data appear. And what this basically is it's taken is vectorized satellite imagery so we can see chlorophyll A concentrations. Now, this isn't current. It's not from today. This is from the webinar that we did for the 2016 harmful algal bloom and major fish kill outbreak that resulted. This is something that we used in a previous webinar. But I'm going to go ahead and turn that off. And I just wanted to call your attention to the IRL and where it is and the data points that are there. But there are some other data sets that are really important to monitoring, water quality and things like that. And that is precipitation. So GeoCollaborate, the real benefit of the technology is that it dives into disparate data servers, portals, and hubs, and can pull that data together into a real-time situational awareness, what we call at Storm Center here, we call GeoCollaborate a collaborative common operating picture. And so if we were interested in seeing how much rain is forecast for the next 3 days in Florida, we can vary the transparency here, but you can see the different contours of how much rain is expected. And these contours are queryable. So in this area in south central Florida, about a quarter of an inch of rain is forecast to fall over the next 3 days. But as you can see up towards the northwest and in the panhandle of Florida, the concentrations for the precipitation are higher. Look at this, 2.5 inches of rain are possible over the next 1 to 3 days here in southern Alabama. And that's because they're going to be anticipating severe weather over the next several days, and it's even higher. Yeah.
Let me just add the point here, just again to make it clear that one of the big differences between screen sharing and GeoCollaborate is when you have a follower who would be following along, they could also query the data. If they're not just showing it on the screen, the followers in a session can also be querying the data, just like Dave is.
That's right. Yeah. Thanks for that, Ellen. And while Ellen was describing that, I just turned on the river level monitors. These are stream gauges, combination of National Weather Service and USGS monitoring. And you can see the ones that are in color are river gauges that are at or above average. If I click on that hydrograph, it immediately goes to the National Weather Service, and you can see the hydrograph for St. Johns River at Astor, and you'll see that it's in minor flood stage right now at 2.5 feet, and it's slowly forecast to go down into some action required. So it gives you that. You're probably familiar with these graphs from the National Weather Service, all because I clicked on this data, and that's really a big benefit from the real-time collaborative environment. As Ellen just said, we're delivering data into your device in a real-time collaboration environment. You're not downloading and saving the data, but you are able to interact with it. Well, how in the world can you do that? How is that possible? It's because we're serving the data as web services. So that's an evolving, rapidly evolving way of making data available without enabling people to download and save it. And so one other piece of data that I'm going to turn on, I'll turn off the precipitation forecast, but that is the sea surface temperatures. So what do sea surface temperature data look like? And I'm going to turn that on here, and I'll zoom out just a little bit more so you can see this. This is actually a global data set from NOAA. You'll see it painting here because we make calls to the server, and they answer my call through web map tiles. So if I zoom out, the system makes another call for a refresh of the data so it can cover that area. You can see, the Gulf Stream coming up here. And so how can we tell what these temperatures are? We can also turn on the marine observations. So these marine observations are real-time ocean observation platforms from NOAA and universities. And so we could dive in here to Florida and click on some of these buoys and see what the water temperature is. 77 degrees. This is right now. This data is updated every 30 minutes to an hour. And you can see the wind, the dew points and things like that, significant wave height, water temperature. So this is a great way to actually validate observations from satellite, because this colorful map is produced from satellite data. And then these are in situ observations. So right here, and they're scattered about. So that's an example of a wide look using disparate data acquisition. So the buoys are coming from the National Data Buoy Center, NDBC, down in Mississippi. And the sea surface temperature data is coming from NOAA NESDIS up in the College Park, Maryland area. And these river level data is coming from the National Weather Service and the USGS. So we're combining multiple agency data for you to see in this one collaborative common operating picture. So I'm going to turn this data off, and then I'm going to zoom in to Florida, because with Florida, there are some other data sets from NOAA and the National Weather Service that may be of interest, and that is river levels. Oh, sorry, I had the river levels on, but the flow anomaly from the National Water Model. So what is this? This is a real-time model that's run every hour from NOAA's National Water Center in Tuscaloosa, Alabama. And they're monitoring the rainfall. They're monitoring predicted rainfall. And they're saying what rivers and tributaries are anomalously flowing. So the green is normal. Red and purple mean above or below average flow. And so here we see, some above average flow on this river going into the lake here. And then we just looked at that river level and saw that it's in minor flood stage. So it's very interesting to monitor this and to know that this kind of data is out there. And that's some of the stuff that we can bring to the table. So I'm going to turn the river flow anomaly data off. And I want to dive into some of the other observations that are taken. I'll turn off the river level data as well. And also I can turn off the IRL data, those observations, which are right here. So that will disappear on the right-hand side of the map. And again, in a collaborative environment, everybody's system is seeing their data turn on and turn off because it's led by a subject matter expert with the on-off switches. And it makes sure that everybody is on the same map at the same time. So what I want to do is dive into some data sets, the wind data, which was formerly STORIT, and we can take a look into Lake Okeechobee. So let me just zoom down here a little bit into Lake O, and I'll turn on the STORIT or wind data, and you can see where observations are taken. These green dots are where observations are taken in the lake. And so that data is also queryable. So you can click on that. You can see information about where it is, what kind of data is taken as well. And there are some other data sets that you can merge into this, because remember, GeoCollaborate accesses and shares geospatial data, also other data like PDF documents and things like that if you want to embed them. But we can do things like track boats. So if there was a boat that was moving around, then we can, let's see, that's in St. John's. Whoops, sorry. Let me just make sure I go to the right folder.
Well, and while Dave, you're finding the right one, the
Yep.
point here is that we can go from looking at satellite imagery to sensor data to a much finer or higher resolution, even looking at a vessel track, whether they're doing monitoring work, you might be releasing something, whatever it is. This just shows the differences in scales and the different kinds of data that can all be unified through GeoCollaborate.
Yeah, that's great. Thanks, Ellen. So this red line here is the path of a research vessel. You know, a small boat that's going in to, maybe it's doing mapping or surveying or spraying or whatever. You can monitor where this boat has gone, how long they spent out in the water, and then went back. So imagine this for rescue vessels. Imagine this for responders needing to go into areas of harmful algal blooms. And then the other data set that I wanted to turn on here is a satellite image. And that satellite image is where possibly HABs could be forming. And so that's a Sentinel data set, but it's also in the, let's see, there's grab samples. Sorry, I have a lot of ideas here for where this data might be.
Sentinel satellite data.
Oh, I know where it is. That's why it didn't show up here. I need to turn it on in the master Sentinel. Sorry. Thanks, KJ. So I'm turning on this satellite image, which is indicating where potential cyanobacteria might be forming. And so now you see it in this green kind of area. So this is how we can use satellite data to identify areas of potential blooms. And then you could have boats go out there and take samples. So we're kind of using a combined satellite as an intelligence gathering device to then point us in certain areas where blooms could be happening. So that's an example for Lake O. And you can see as you zoom out, the data resolves and you can see the points and the boat track. But the same kind of information is available in Tampa Bay. And that's what I'm going to turn on the wind data here for Tampa Bay. So you can see those observations as well. And I can make it a little bit more clear. I know I have the satellite base map on, but if I turn the street base map on, where you can see the streets and all that stuff, then those observation points become even more clear around Tampa Bay. And so any of these points are clickable as well. You can take a look and see what the data is, where this information is being collected, when it was collected, all that kind of stuff, what the readings are. And so I'm going to travel now, take you down to Southwest Florida, because there's additional applications. Remember, these are all from disparate sources, disparate trusted sources. So the great thing about GeoCollaborate is that we're tapping into those trusted data providers who are processing the data, QCing the data, making it the best data possible for evaluation or for the research. And we're pulling that disparate data in together so we can all look at it. No more do you have to go to this website and then this website and this one. Some people go to 10, 15, 20 different websites just to get an idea for what's going on in a certain location.
And Dave, while you go down and change bring up some of the other data sets, I just want to say, we're demonstrating all the different things that you could do. Imagine if you had photographs that you wanted to confirm a bloom, you could bring those into GeoCollaborate. You could combine the boat track with some model data. So again, we just want to show the different kinds of data sets. And again, we're mostly focusing on things related to harmful algal blooms for now.
Right. Yeah. And thanks, Alan. And what I'm about to turn on here is a red band difference in Southwest Florida that shows the potential for red tide. And this is being taken by the Copernicus Sentinel-3 satellite, which is a European satellite, and is being processed by NOAA and NCOOS. And they're making that data available as geotiffs. We can take those geotiffs and turn them into web map tiles for immediate consumption into GeoCollaborate. So now we can do some daily monitoring of potential red tide. Now, I do want to make sure that this is not today. This is when we took this data, I think it was late October, early November, and you can see where the red tide was, potential red tide in this area. We know it's migrated further north now. But again, this is something that could be used in a public-facing website. It could be a public-facing dashboard, or to help decision makers within the state of Florida determine what actions they might need to take because they're seeing this kind of activity on satellite imagery. So I'm going to back up a little bit. I'll zoom out just to show you the swath of this particular data, which is here in Southwest Florida from Tampa right down here. You can see the swath of that satellite image, and the same one for Lake O. That's what I used to show the potential bloom there. And I'm going to turn that off because I'd like to then take a look a little bit more broad through the state of Florida. And that is, if there is a bloom, if there are fish kills, then there's going to be a need to put some boats in the water and collect those fish or do whatever. So there are boat ramps, there are other sorts of infrastructure data that you can bring into GeoCollaborate and share that for all of the followers. And so, for example, as I turn on the boat ramps around the state, you can see that data comes from FWC.
Right. And Dave, let me just clarify that KJ specifically winnowed out the boat ramps for those 3 areas: Indian River Lagoon, Lake Okeechobee, and Tampa Bay. So we could do more, but she had filtered out specifically. We were interested in the boat ramps in those areas. And remember, one of the important things to also remember is that we're not downloading the data and reserving it. So we're never changing the data. The data comes from the trusted source as is. And because I know that's always an issue for people, is you don't want the potential to change the data. And we're never doing that here. So
hey Dave, I got a question in the chat from Rich Paperno. He wants to know, how do you change the time frame of data to look at? So the temporal scale.
great.
Yes. So that's a great question. You can change that. Goes into that's from the data provider. So anybody who is serving their data, they can create a specific time frame and specific data that they want to serve, and then make that a web service link. And so that web service link would then go into GeoCollaborate, and it'll display only what the data provider wants to display. So one way that you can really take advantage of that capability is by creating several different web links for different times, different parts of the year. If you want to archive data, you can keep looking at that particular archive. And this goes right back to the data provider because they're in control of the data that's offered. GeoCollaborate is the technology that accesses the data through the web service and make sure it's shared out across all collaborators in real time. So it's really that last mile of data delivery that GeoCollaborate focuses on.
And let me just add to that, the data provider can also set it up so that it's automatically updated. Just like Dave was talking about with the satellite, which automatically updates. If there's a web service they would like to, and we'll get to the dashboard where it could automatically update, and then you'd get the most recent data. So again, that's up to the data provider. So yeah.
And if you need any more clarification, please put that in the chat. That was a great question because the NOAA data, most of the NOAA marine observation data that we pull in directly from NOAA is updated in real time. As a matter of fact, when you look at the satellite data and the radar data, you'll see when new data comes in, the rain showers move and shows progression. So there's no delay in the type of data, and the data provider can set it up however they want.
Right. So I think there was one other data set that we wanted to show that was sort of statewide. And again, thanks to KJ, she filtered out 2 years of manatee mortality, because we know this is a big issue statewide. But again, you could have a leader follower session where you're looking at where those are occurring. You could have a public facing dashboard that had where those were occurring. but here we have those manatee mortality sites within the last 2 years. Again,
Yeah.
just as an example.
Right, and you can see that they're scattered throughout the state, and so it really does take utilizing data, geospatial data, to the next level because you can determine, the data provider can determine what you would like to release, how long you would like to release it, and how you would like it to display. So KJ picked the icons to use. The data provider is really in control of how it displays on the map. GeoCollaborate is the access and collaboration environment to pull it all together in those different devices.
Thanks, Dave. I think now we're going to talk a little bit about, so we've shown model data, satellite data, sensor data, even boat tracks, all different kinds of data, but I know there's other types of data that out there that we haven't shown or might be particularly helpful for harmful algal blooms. So we want to give Chuck a chance to chime in here. Chuck, what are we missing something, or how could this, what other types of data do you think would be helpful that could be brought in to GeoCollaborate to unify with other things?
So I think, we've touched on a variety of things that are useful. So predictions of, forecasts of weather and things like that can drive the way blooms behave. We were just talking earlier that it's, cloudy and raining over there, and there's a bit of a bloom going on in Banana River Lagoon, and we'll see how the clouds affect that. But generally speaking, in the bigger picture, I think it's, it's some of these things where we move away from hindcasts, so looking back at what happened, and nowcasts, which is, even what's going on now, to forecasts where we can say, we use a hydrodynamic model, for example, that, could move the particles in the bloom around and show you where it might end up. Or again, using the expected weather conditions in a sort of medium term seasonal kind of way, and predict whether this looks like, given what we know about how weather conditions are likely to go, is this going to be a rough year or, not a rough year? So I think a lot of what we have to do in order to really make use of this tool is for the people who work with harmful algal blooms to decide what are some of the best products you want to display. And then, this allows you to display those and match them up, again, match up targets built in different ways. So.
Right. How about Dwayne? Do you have any thoughts on that? I mean, particularly, we haven't really talked too much about response and management. Any thoughts there?
Sure. One of the things we recognized back in 2016 during the brown tide bloom, and many of you may remember a historic scale of a fish kill, is that we had multiple target audiences looking for different types of information. And so the idea of, how do you better not just communicate, but coordinate and collaborate? And so understanding your situational awareness at the moment, is one level of spatial, and temporal information that, some of our stakeholders needed. The media was, screaming for information, in particular, wanting to know, if it was safe to go in the water, where was it safe? Where was it unsafe? Many of our partners, whether it was cities or counties, were trying to make really operational decisions about where to put a dumpster and where to deploy boats. Did we have permits, to pick up fish? And if you had dead fish, where do you properly dispose of them? So I think the aha moment for me through this year of applying this technology to harmful algal blooms is that any user and any organization, could take a tool like GeoCollaborate and then fine tune it and customize it to your needs, where you control the information that you want to get out and the way you need to have it. Everything from real time, where you may not have a lot of QA/QC, to, and Chuck was talking about it, the hindcast. I think for many of us, and I was reminded of the challenges of this just last week. I attended 2 federal state interagency hurricane response and recovery meetings and hearing some of the stories of the really complicated coordination efforts, including, trying to save lives, who was deploying, to which streets and which houses, where you thought you had people stranded, so having this type of technology has lots of potential value. And then the challenge and opportunity for organizations, whether you're doing research, response, recovery, or just, understanding the monitoring, situational awareness, is deciding how you want to employ the technology to your needs,
Mhm.
And then you'll see in a minute, what the dashboard,
Right.
where you're not on the phone every minute, but you could set up a dashboard, and those individuals or stakeholders who are needing information, know where to get it, with some time frame, without those of us who were in those moments having to take dozens of phone calls and verbally try to tell people what was going on. So I think that's the lesson learned for me, is that there are technologies that can make this easier, more effective, more efficient, and most importantly, in the response frame, more useful to the responsibilities and authorities of some of our organizations.
Yep, that makes a lot of sense. And it reminds me that one thing we didn't really say yet is that this can be brought into any device. So it could, as long as the internet is available, you could bring it up on a mobile device out in the field. So, and be part of a collaborative session, and bring up the dashboard. And I see, before we go on to the next thing, I see Dave has been working hard to set up a geospatial message. Dave, what have you been doing now while we've been talking?
I was just making the screen move while Chuck and Dwayne were talking. But essentially what I did was I used satellite imagery to guide geospatial message issuing of, that this might be a possible bloom area and we'll need to monitor it. But it could be specific messages internally in a collaboration environment where you're saying, hey, we need to get a couple of boats together and take some more samples here, because the satellite is kicking off some potential interest we might have in a bloom. And then you can gather more data and get more information. So it's a way in which you can direct people, or if this were public facing, say, there's a potential bloom here, enjoy these areas of the lake to go into, or these areas of the IRL to go into while we're taking a look at this area. There's all sorts of coordination and collaboration capability that
Dave,
exists. Yeah.
Before you jump, I just want to use this as a really good real-time example. And so if in fact this was a microcystis bloom and we had data for aerosol microcystin toxins, and you had wind directions, you could use this data to better understand communities at risk, for example, for aerosol, toxins. And so it's a really good example of where you can combine the meteorological data and the harmful algal bloom data and begin to look at communities that may have human or animal health risks based on the data sets that you have at the time. So it's just a good example on Lake O, of a real-time concern that many of us who are doing HAB discussions are concerned about, human health.
Yeah, that's great. Thank you. Thanks, Dwayne. Feel free always to jump in, and that's great. And one of the things you mentioned was these emergency response, because of what has happened recently with Hurricane Ian. And so there's this whole issue. What about how could GeoCollaborate be used not only in forecasting and in preparation, but in response, and not from the emergency management to the science? And so we decided to take a quick look at a couple data sets from Ian to see how it would fit into GeoCollaborate, just to show you again, give you an idea of talking forecasting, preparations, and then afterwards, how we might be able to look at some data sets. So Dave, you want to take a look at some of those?
Sure. Did you want to talk to talk to KJ at all before Hurricane Ian on the data, or do you want
No,
to?
we're gonna talk about this and get to the data a little bit later.
Okay, cool. Whoops. Oops. Sorry. I clicked stop screen sharing. But let me sorry, let me click screen share again.
While you're pulling that
Over
up,
here.
Dave, just for everybody, Dave was prominently, online during the approach of Hurricane Ian and watching these YouTube presentations. And he's going to talk about this a little bit. Really in my mind, I went, wow, this is, the real power of the GeoCollaborate platform, is when you're hours away from, a landfall and you're trying to get real-time information out as fast and wide as you can, in a way that's pretty easy to visualize and also communicate. So Dave, congratulations on that. I thought that was really impressive hours before Ian landfall.
Thank you, Dwayne. It was a tough forecast to be communicating from the National Hurricane Center with so many people that were so vulnerable in Southwest Florida, and with that storm, really just taking a path towards the southern part of the cone, caught people sooner than they may have expected. But the forecast was excellent from the National Hurricane Center, and what we try to do is put these YouTube videos together. And then we make these videos available through GeoCollaborate. So any of you thinking about, gee, how can we use this kind of environment? One way is to just make more data available from a single collaborative location, including videos that can keep you updated on things that are going on and could lead to new videos being produced on certain topics. So Ellen mentioned, and also Dwayne, Hurricane Ian. I wanted to just show a couple of data sets from Hurricane Ian, starting with the advisory from the National Hurricane Center, where they have a brand new product. Actually, it's new over the last year or two, so it's going to take a while, I think, for people to understand how they might be able to use it and understand it. But one of the things that the Hurricane Center issues are storm surge, maximum storm surge potential graphics. And they try to make it very easy to understand so people along the coastline don't have a lot to think about. They can just see this number. And so this was the actual forecast for storm surge, peak storm surge for Hurricane Ian. And you can see these colors. What do these colors mean? Well, the benefits of geospatial data are that you can zoom in. Here's Naples all the way up to Fort Myers and Fort Myers Beach, and you see this purple area here that is highlighted. And when you click on that, that was a 12 to 18 foot storm surge forecast from the National Hurricane Center prior to Ian making landfall. And so this was a very sobering forecast that kept getting, updated as the storm was getting closer. And even down in the Naples area, this red is 8 to 12 feet. And I believe that most of the post-storm surge surveys that are being done are finding numbers in the Fort Myers Beach area of 15 feet, some areas maybe a little bit more. So this particular product is issued for every potential landfalling storm. Even up in Tampa Bay, the storm surge, let me just click on the right thing, 4 to 6 feet. Included Tampa Bay for this particular advisory. Now, the storm was so strong and the winds were offshore in Tampa Bay, so it actually drained Tampa Bay. They ended up, though, with a 1 to 3 foot storm surge. I think as the storm made its way inland, this was downgraded just a little bit to about 1 to 3 or 2 to 4 feet, which verified. But you can see even on the east coast of Florida, there were peak storm surge numbers issued. Daytona Beach, from Flagler, Volusia County line down here of 1 to 3 feet, which verified, which unfortunately weakened the beach prior to Hurricane Nicole. So
again, let me just say, as an example, this is an example. There's other things that could be brought in, like the cone, the forecast cone, other things, the wind field, all of that can be brought into GeoCollaborate. What about post-storm, Dave? What are some of the imagery that you found with regard to the after the storm, the aftermath?
Yeah, so this is an example using NASA and NOAA satellite imagery. This is what the area looked like before Ian made landfall, and you can see that there's, you can see some ocean color there and some sediment and things like that. But once all that major rainfall fell inland and caused all of that flooding, it was pretty amazing what the area looked like with this sediment that was just being flushed out of these rivers and tributaries, and even from Port Charlotte out into the Gulf of Mexico. So you can see this dramatic water turbidity coming into the Gulf of Mexico. And we can even use another satellite. This is from the Sentinel-3 satellite, which is a European satellite that has a kind of a smaller swath, if you will, from data gathering. I'll turn that off, but I'm going to turn off the sediment before Ian and just show you how broad the impact was for sediment from Ian. And I'm going to turn on a MODIS satellite image and show you just how broad and wide that sediment went out into the Gulf of Mexico. I mean, this is all sediment.
Right. So you can imagine, everybody can imagine, for science and coordination of science and research, you could combine this with going out on research vessels, taking measurements. You could plot the tracks. We could use some sensor data. We could use model data to combine. Again, so this idea of unifying data from different sources, pre and post storm, could be very helpful. This is great, Dave. How about, why don't we move on? Please, again, I'm going to say, if you have questions, put them in chat. We're open to questions as we go. We also wanted to move and take a look at the dashboard. Well, every time you do an active leader follower session, you automatically create a dashboard that is available 24/7, 365 for users to go explore all the data sets that you've put together on their own.
Mm-hmm.
So as Dave is bringing that, again, if you have any questions, please bring that up. Feel free to put them in the chat.
Yep, that sounds good. I'm going to bring up the dashboard here. I stopped sharing just to make sure that when I reshare, I'm resharing the dashboard. And so I'm going to share again. Here we go. And this is the dashboard from the collaboration session. And what you can see is a little bit different. You can see the logos up top. You can see the layer list. These are the layers that were loaded into the GeoCollaborate session that are now available to all of the collaborators. So any user of the dashboard can turn on and off their own data layers. Even more important here is you have total control of the map view. So rather than have the leader control the map and where you're zooming in and looking at and turning on and off data, each individual user of the dashboard can control their own view that they want to see. So that's moving around. You also might notice this key points window. This key points window is kind of like a one-way chat from the leader, where they can put in important information into the chat, such as, the date that this is being issued, what bullet points are important. Dwayne mentioned Hurricane Ida or Ian updates. This is a link to that YouTube channel. I won't play it, but when you click on that, it opens up the YouTube video, and then you can watch that YouTube video and then go right back to the dashboard. Information like when is the next update coming in GeoCollaborate. If you have live data displayed, it's always updated, but you might have a briefing that's scheduled, and then you can say, stay connected through the dashboard, click on that to go to that briefing or to bring that up. Now, you might say, why are you clicking on the dashboard link if you have the dashboard already open? But these key points are already also shared through all of the follower instances as well. So if somebody doesn't remember the dashboard, how to get to it, they can just click on that link and it'll take them right to the dashboard to look at this information. So this is just an example here. I'll turn on, one of the data layers of the river levels. So remember, we showed the river levels earlier on in this demo, in this webinar, Zoom meeting, but each one of the users can individually turn on the data set that they're very interested in. And then you can turn around and use this as a briefing tool yourself. So this is a way we can use the dashboard to connect with the media. Any TV station out there that's going to be on the air, or any government official, state official, county official, can turn around and use this dashboard as a briefing tool. And that is by going into briefing mode. And when you go into briefing mode, you have the legend that appears, and that can be closed or kept there. You have the key points window that can be closed or kept there. But here's the thing, you now have a fully interactive, full screen, geospatial look at the situation. So you can dive right in and start pointing things out on a big monitor to the media. And then even the media, could take this full screen and show it during their newscasts and briefings. So you can point out what the significance is of this massive amount of sediment. What does that mean to the, marine life or whatever? And then you're seeing the clouds and all that kind of stuff too.
Thanks.
So, yeah.
Thanks, Dave. That's great. So now we've kind of seen the dashboard. How could you be used for the public? We've talked about how the dashboard and the collaboration sessions could be used for scientists, for verification and validation of data. Also, emergency responders. Dwayne mentioned a few in emergency response could be using this. I think one of the valuable things here is that you have a subject matter expert who is essentially customizing the data, choosing what data should be showed for which audience. That's a really important thing, because oftentimes when you go to portals, websites, it's kind of overwhelming and you don't really know what you need from where. But in this case, depending on who your target audience is, you have a subject matter expert that decides which data sets are relevant for that audience and can put them in the collaboration session, and then they're up on the dashboard. Again, if you have questions about the dashboard or leader follower sessions or what we've been showing so far, please remember to put those in the chat, or you can raise your hand and we should be able to see it. But a few minutes, I'll pause there for just a second to see if we have any questions.
And Ellen, I know KJ's got some information about data we want to make sure we share.
Let's go to that, because it actually is one of the most frequently asked questions, is about how do you integrate the data, what kind of data, and how to be QA QC. So let's go to KJ.
Hi, everybody. So again, I'm just going to kind of reiterate on kind of like the data movement and data process of putting it into GeoCollaborate. So this was kind of a point that came up a lot. Data needs to undergo some sort of quality assurance and quality control in order to be used for regulatory decision making, but that doesn't mean that you can't bring other data sets like in conjunction with it. So provisional data can be used for informational purposes and be easily brought into GeoCollaborate as long as it's as a web feature service. There's flexibility to talk about your data sets, and there's also the ability and the capacity within GeoCollaborate to kind of put like a disclaimer, which is great because I know a lot of agencies kind of focus on that. And then data accessibility as a web service URL is the future for data use and data sharing. So I've been in contact with FWC, FDEP, the water management districts, and they've been great along the whole process. It's been wonderful. But having those conversations about moving data to web services, so you don't have to send large SQL databases or send either Excel files or CSVs, is kind of the way of future data sharing. So a lot of questions that I've been getting, what I've been thinking about is when you're getting when you have the data, who is your audience? So who's going to be using the data set that you're looking at? What do you want to focus on, whether it be your data and your data type? where's the main focus? Who do you want to share it to? And then where do you need to collect the data for it to be most useful? So I think I've mentioned this in some of my other presentations, it's impossible to sample everywhere. So strategically planning where you're going to be sampling or where your data is collected to show an overall view is very important, especially once you start getting into those modeling. So these are the current data sets accepted by GeoCollaborate. I broke it down into raster and to vector data sets. So everything from dynamic to web map services to KMLs, so from Google Earth, real images, image tiles, geopics, geolocated photos and videos. There's a lot of different raster formats that can easily go into GeoCollaborate. You just need that URL. Same thing with vector data sets, so KMLs, GeoJSONs, feature services from ArcGIS Online, PDFs, CSVs. You can incorporate them into GeoCollaborate. It's pretty straightforward. You can either see at the bottom, there's some additional formats that can also be added. GeoCollaborate's really great at kind of expanding their data set, their data sets. So if you have another data sets of how your data is hosted online, you can have that active conversation with Storm Center. Security and permissions and access. It's important to note that data is only being viewed within GeoCollaborate and it's not being downloaded. So there's no room for interpretation or change in the original data set that it's being viewed. I could apply filters and like to geospatial filters if I wanted to. But other than that, like it's exactly how the data provider wanted it to be seen. Also, the accessibility to data is controlled by the providers. So if data providers make it public, then we can bring it into GeoCollaborate. But if there's a permission, we would need to go through that permission process as well. It's important to note that credit is always given to the owner and the creator. That's whether it be in the metadata, so while you're actually clicking on those services, or we can put it in the feature services layer name. GeoCollaborate's leader is also password protected, so that's kind of really important. So if you don't want people knowing where some of your data is housed and it's maybe publicly accessible, the only people who are going to be able to see that URL link, unless they want to share it, is the GeoCollaborate's leader. Also, links can be provided to other user portals and hubs for more information. So these are the main takeaways that I've gotten from this project because it's been very complicated going through the quality control process of other people's data sets. It's really important to understand the purpose, the audience, and kind of the 5 W's for data sharing. It's also super important to make sure that your data is accessible to bring into GeoCollaborate. Also, data configuration and integration into GeoCollaborate is easy once you have that web service hosted. All right, and was my little spiel.
Thanks, KJ. We really appreciate that. And we're going to start the wrap up here. We're going to begin with a rapid fire. Give me your 1 or 2 takeaway real quick, and then we're going to move on to Dwayne for overall project wrap up. So 1 or 2 real quick wrap up from your perspective. Chuck Jacoby, go to you first.
So again, I kind of go back to this concept of having a tool that prompts us and challenges us to pull together disparate kinds of data. So for things like water quality, we have SOMs that measure things in 15-minute intervals, and we have monthly samples and so forth and so on. And it's trying to pull all that together to provide the kind of information somebody can make use of. I think that's a challenge.
Great, thanks. Dave, to you.
Yeah, I think as we have gone through this process in developing GeoCollaborate through the SBIR program, federal government, what's been really key is that the ability to access different data sets from disparate locations has proven really effective because it provides the data providers the opportunity to quality control their data, make it available very quickly. If they want to turn it off, they can turn off the data feed if they really need to. But bringing disparate data sets together in this collaborative common operating picture is really launching the ability to have collaborative decision making between people who are dispersed, separated by distance. I think we've really seen that as being one of the most effective things.
Okay, how about Dan? We haven't heard too much from you. What are your thoughts on the rapid fire takeaway? Go for
I
it.
think my takeaways touches a little bit on what Dwayne mentioned earlier on all the different users and how this dashboard that Dave showed can be really helpful for different user types. So, you know, if you have your emergency responders and you're looking at close to real-time data and they need to make a decision, they can then filter that down to, say, a public-facing dashboard and have those advisories or you know, health information during those events. You know, and then you can also have scientists and data interpreters using this to collaborate and take multiple types of data spatially and temporally to evaluate conditions and provide valuable insights that could ultimately lead to smarter decisions. So there's a whole range of different users that could have this dashboard and have different information displayed. So I think that's very powerful.
Okay, thanks, Dan. And so now I'm going to turn it back to Dwayne to wrap up, and we'll have some more time for questions as well. So Dwayne, to you.
Thanks, Ellen. I want to just reiterate an important point. This is the beginning of a discussion. It may be the end of the project, but it's very much a beginning of a discussion between the National Estuary Program and our partners about, you know, how do we communicate? How do we share data? You know, what are the technologies available to us? And so from a project standpoint, what happens next is that we're going to take all of your really good questions, the discussions from each of these 3 sessions, build a final report for DEP, which we'll make available to our entire management conference and our partners and all of our participants. And that report is going to include a SWOT analysis, you know, looking at, you know, how GeoCollaborate could be used for harmful algal blooms. You know, what were some of the challenges, the strengths, some of the weaknesses and things we need to address. And there's no question, you know, a lot of those questions are the front end issues of data quality, data QA, QC, and data availability. And so over the next couple of months, we'll be building that final report. We'll be bringing that back for discussion with the Indian River Lagoon National Estuary Program Management Conference, and then having a larger conversation with our partners about where do we go from here. The National Estuary Program, you know, is in harmful algal bloom monitoring, you know, and information sharing for the long haul. And we want to make sure that we are serving you, our stakeholders and partners, your needs the best. So even after we end this session, if you have thoughts, please contact my staff or I. If you have an interest in looking at GeoCollaborate, possibly as a tool for your own organization, give Ellen and Dave a call directly so you can talk specifically about maybe what your, you know, individual organization needs and responsibilities are. But I want to end by thanking you all for your time and for hanging with us over this year, having these discussions, and especially thank DEP and the Harmful Algal Bloom Innovation and Technology Program. You know, without that funding, you know, these kinds of beta tests and technology testing opportunities wouldn't happen. And so DEP, thanks for your support there. And then Ellen, I'm going to just turn it over to you to end the session and see if we have any additional final questions from our participants today.
Okay, thanks, Dwayne. And Dave is putting my contact and Dave's contact in the chat. So if you would like more information about GeoCollaborate, please get in touch with us. There's also a website, geocollaborate.com, that has just been put in the website. You can learn more about it. But we always love to talk about it. We see lots of uses. We're very excited. And again, we want to thank all the members of the team from the IRL, Chuck and Dennis, and certainly DEP. Are there any more questions out there? Please, if you've got, you know, sometimes people on these things are hesitant to ask, but we really value the questions and being able to have a conversation.
And one last thing, while you might be thinking of a question or two, because we got this yesterday and we had the webinar about the development of GeoCollaborate. It was developed, for those of you who haven't attended the first or second webinar, it was developed under the federal government's Small Business Innovation Research Program, SBIR, which was hosted by NASA. We addressed a grand challenge from NASA on how federal agencies can improve access to data and data sharing and sort of data-driven decision-making. So that's how GeoCollaborate got its start, and it has evolved. And we've gone through all of those phases of SBIR, and now we're at phase 3, which is very good for small businesses in that any federal agency can license and inquire or acquire GeoCollaborate on a sole source basis for any time frame with no set ceiling ahead of time. So it's made it good. We're now working with NOAA, we're working with DHS and NASA, and we've also recently received funding from NASA's Applied Sciences Division from their new wildland fire program. So we'll be putting more wildfire data, getting more information in to GeoCollaborate about wildfires, which will extend throughout all of the instances of GeoCollaborate. So if those of you are interested in tracking wildfires and impacts of smoke and things like that, we'll be getting more information. We have a lot in there now, but we'll be getting more information into GeoCollaborate as the time goes on. Ellen?
Thanks, Dave. Anybody else? Any last minute questions? We've gotten some nice thanks. Thanks, Gregory Wilson, for your nice comment. Excellent tool and presentation. We appreciate that. We like sharing this, and it's been I think it's been kind of a learning opportunity for all of us to learn from different perspectives of, what are the strengths, what are the weaknesses, where the struggles are. And I think it's been good for all of us working together. It was just what you would hope. Okay, if there's nothing else, Dwayne, do you want to sign us off?
I just want to say,
wait, I take
I
that
see
back.
Rich has got a hand up. Good for you, Rich.
What? It's not a hand up. I was just giving you applause. I thought it was a good presentation.
We'll take that too.
Well, I just want to thank everybody online with us today. Wish you all a happy and safe holiday season. We'll see you back in 2023, but don't hesitate if you have follow-up questions. I put KJ's contact in the chat. You know how to get to me and my entire team, and just everybody enjoy your holiday, and thanks again for your support.
Great. Thanks, everybody.